All right, today what we're going to do is we're going to go over two more problems and then go through some
Yes,
formulas. Hello, Steve. All right, so here I have this one. I have 5x squared minus 2x plus 5y squared minus 12. First thing you're going to do when you start one of these problems is you have to find. You're going to have to find the angle of rotation. So you're going to use that formula cotangent 2 theta is equal to A minus C over B. So I'm going to have 0 over -2, which is just be 0. This one we've seen before. We know that theta is going to end up equaling what? 45. We've done quite a few with theta equaling 45. So I know that x is equal to, using that formula, x is going to equal the square root of 2 over 2 x prime minus the square root of 2 over 2 y prime. And then y is going to equal the square root of 2 over 2 x prime plus the square root of 2 over 2 y prime. That's from the formula sheet. Now what I'm going to do is I'm going to go back to my original equation. Any place I see an x, I'm going to substitute in this equation, and anytime I see a y. So this will be my x. This will be my y. And there's a lot of knowing Algebra 1 involved. Well, here we go. So the first one is 5x squared, so I'm going to write 5, and then I'm going to do the square root of 2 over 2. I'm dropping the prime symbols because they get confusing after a while.
We just write it out as 2 to start.
Pardon me?
We just write that as 2 to start.
Yeah, if you want.
Like 2 separate ones?
Yeah. I'm putting the 12 on the other side. No, I'm not chunking. I'm just highlighting which ones that's supposed to be.
Will chunking be ineffective?
No. Oh, I wonder. I don't know. I thought about that.
Wait, just let me highlight.
I need to move on now. Move on. So, off to the side, and while here, we can't do the off to the side with Steve, sorry. Okay, so here we go. If I have A minus B squared, do we not agree that that's A squared minus 2AB plus B squared? And have we not said that the square root of 2 over 2 squared is equal to 1/2? So when I go to do this, I'm going to have this, the square root of 2 over 2x minus the square root of 2 over 2y, and we're going to square it. I'm leaving the 5 outside. So this will end up being 1/2 x squared minus 1/2 y squared.
Would you want to just put the x squared and y squared in the numerator?
Let's do that. I'm okay with that.
Okay.
That'll save me some room too. That's good. Now, the next one, I have the square root of 2 over 2x, square root of 2 over 2y. One has a plus sign, one has a minus sign. What happens to that middle term? It goes away. So I'm going to have the 2 out here in front, and then this will end up being x squared over 2 minus y squared over 2.
So it's the same.
Oh, you guys make a back out.
Oh my sheets.
I got the middle term here, guys. Oh, I have to. That would be 2xy over 2.
I'm running out of the negative.
It's 2 and then square root 2 over 2. 1/2 times 2, yes, it's 1. I'm gonna leave it over 2, so I define it down there.
Wait, what does that say?
2xy over 2. I'm doing it. My square root over 2. No, because negative times negative will be positive. So that's that. Now last one, 5, not gonna mess up. X squared over 2. This is gonna be a plus sign. Okay, now I'm going to distribute my 5, my -2, and my 5. So I'm going to have 5x squared minus 10xy plus 5y squared. That's all over 2. Can I do it like that? And I'm going to write, well, everything's over 2, so I'm just going to write everything over 2. Minus 2x squared plus 2y squared. How can I get rid of this 2 in the denominator? A negative times a negative makes that a positive. Okay, I'm going to multiply both sides by 2. 2.
Well, why can't you just cross out those 10 xy's?
I'm getting you. I'm going to combine my like terms. So first thing I'm going to start with is x squared. So I have 5x squared minus 2x squared, 5x squared. So how many x squared do I have?
8.
8x squared. I'm going to do my xy term. My xy term, I have negative 10xy. And I have a positive 10xy. They cancel out. If you are left with an xy term, you made a mistake. Because that's the whole point of doing this, is to get rid of the xy term.
In all these types of equations? Like you're never gonna have
It makes
xy?
it easy to graph. Yes, actually, having the xy term in this original equation tells me that in order to graph it using my Times formulas, I have to rotate the axis. So when I'm doing all this, so I get rid of the xy term, so I can graph it the way I graphed it before. Then I have,
I wish.
if I do it right, it's all cancel. That's the whole, pretty much. So I end up with 12, I think. So plus 12y squared is equal to 24. Divide everything by 24.
That's good.
So this will be x squared over 3 plus y squared over 2 is equal to 1. What shape is it? It's an ellipse, so to sketch this ellipse, here's my x and y axis. Here's rotating at 45 degrees. This becomes x prime, y prime. I'm going to actually pick up my paper and rotate it, I think. So my center would be at 0, 0. And then, did I rotate that around that top? Then, square root of 3 is 1.7-ish,
Yeah.
and square root of 4 is 1.4-ish.
2, you mean?
Yes, that's right. So I'm gonna go over 1.7, 1.7, 1.2, 1.2, and then I'm gonna sketch my oval. Like that. And then I put my paper back. Now that wasn't bad, right?
My oval and these.
Oh, poorly drawn oval.
You
Oh,
put the 1.4 in the last.
Yeah.
yes.
In the word, how'd you get that other? Did you make a bunch
What?
How'd you get 2 points out of it?
So my center's 0, 0.
Yeah.
So my vertices, remember, my center's 0, 0, then my major vertices would be plus or minus square root of 3, 0. So 1.7 to the left, 1.7 to the right. And 1.4 up, 1.4 down.
Both that would be plus or minus 5, 0, right? There's plus or minus square root of 5, 0. Sure.
All right, so look at this. This one I believe is on your
Thank you.
note sheets.
Thank you.
I have the hardness of writing something. So when I go to do this, I'm going to start with every single one you find angle rotation first. So we'll say cotangent of 2 theta is equal to 4 minus 1 over 4. So I get 3/4. That is not a value that I recognize in my unit circle. So the first thing I'm going to do is I'm going to find the actual angle that I'm going to rotate. This involves me using my calculator. So I'm going to do, since I have the cotangent of 2 theta is equal to 3/4, and I want to find my angle, that means you have to use the inverse function. So I'm going to do the inverse cotangent of 3/4. That's going to equal twice my angle, and then I'm going to divide that angle by 2. So I'll give you a second.
46 degrees.
Is it 46 degrees?
No, I lied.
There it
I lied.
Wait,
I forgot to convert it to degrees. It's okay. I am stupid. It's 26 degrees.
Is it, that's after you divide it by 2, right?
I did not do this one.
Is it?
Yeah.
Yeah.
Yes.
Oh, yeah, that's it, you divide.
I have to wait and check my own math.
So after you, so what was 2 theta equal to? 56 something? That's
Oh, no. The 2 theta is 53.1.
53.1, and so 1 theta is 26.6 degrees? Okay. Well, here's the thing, when I go to graph this, I do not want to deal with the cotangent of 26.6 and the sine of 26.6, because that'll give me decimals and that'll be really, really hard. So I don't want to do that. That's what brings us to our favorite formula
No.
for half angles.
It hurts.
No.
So when I go back up here, 3/4. 2 theta is going to be my angle. My cotangent is 3/4, which means my adjacent over my opposite is 3/4. If I were to draw this triangle the way that is, what would the hypotenuse have to be?
5.
5. Which means if I want to find, so I'm given 2 theta here, right? And I want to find 1 theta. So I'm going to use the half angle formula. When I look at this, it's kind of like I'm going to do the sine of theta is equal to plus or minus the square root of 1 minus cosine 2 theta over 2. That's what I'm doing because I'm using the half angle theorem.
So why'd you change the equation?
Because last time I had to multiply both of these by 2, so then I had 2 theta and then theta. Yeah.
Doesn't matter which one you choose.
I'm going to have to use one for the cosine and one for the tangent. So you know how the formula, so when I go to do sine of theta, the sine of 1 theta, I'm going to say that's going to equal, and then it's going to be 1 minus the cosine of 2 theta. Well, the cosine of 2 theta will be 3/5. Everyone go with that?
Just read out.
Over 2.
So we're focusing on the triangle.
We're focusing on the triangle right
Look
now.
also, how did you draw that triangle? Where did you get 2 theta?
My cotangent is 3/4. So I do a triangle where I put 2 theta, because that's cotangent 2 theta. Its cotangent is adjacent over opposite. So I do 3/4. I can do the Pythagorean theorem, but you should really recognize the 3, 4, 5 triangle, so the hypotenuse has to be 5. Based on this triangle, the cotangent of 2 theta is equal to the adjacent over the hypotenuse, which is 3/5.
Okay.
So now I have this in here. So the sine of theta is equal to, this will end up being 2/5 over 10, right?
Wait, how do we,
Oh my gosh, people.
wait, Ms. Ward, how do we know we're using the half angle formula for sine and not cos?
We have to do both.
Oh, okay,
I just happen to do sine first.
okay.
Isn't the cotangent
It is. Oh.
I didn't hear that.
So then this will end up being, so that'll be 2, this ends up being 2/10, right? Which ends up being 1/5, yes? So the sine of theta is going to equal 1 over the square root of 5. And I'm going to leave it like that. I'm not going to rationalize it. It's just a work in progress, yes, not.
So like from the beginning, when you started using this half angle formula, you could say sine of theta instead of sine of theta over 2 because the original one we had was 2 theta.
Yes, okay.
Okay, that makes sense.
We're just going to make them possible. And you want to know why? If I go back up here, my angle's 26 degrees, so both of them are going to be positive. Okay, so that was the sine. Now I'm going to do the cosine. The cosine of theta is going to equal the square root of 1 plus the cosine of 2 theta, which is 3/5, all over 2.
Sadly, and that's before you even have to do the other stuff.
Yes, yes, she's exactly right.
Ray, I hate this.
So this will be 8/10, which will be 4/5. So this ends up being 2 over the square root of 5.
I gotta go eat. Sure.
That's just to find the sine and cosine. Now I'm going to go back.
Oh my god.
Yes,
You like that?
yes.
This is like the worst thing, like
I've ever done. I feel like I'm gonna lose.
Oh my.
All
All right, here's the formula to remind you what the formula was. The cosine of theta is 2 times the square root of 5, and then that's x. So 2x over the square root of 5.
Wait.
The cosine we just said was 2 over the square root of 5.
Yes.
So I'm doing 2 over the square root of 5x. Minus the sine I just said was 1 over the square root of 5 y. That's x.
Forget your primes. Can we multiply by square root of 5 or something? That's complicated.
I'll get there. Y is equal to, do I have to write the formula? Probably. So y is equal to the sine of theta x plus cosine. So y is equal to 1 over the square root of 5x plus 2 over the square root of 5y.
Oh.
Go back up to that equation.
Oh, Nukti, I want to write that.
So I have 4x squared. 4x squared. I'm dropping the prime signs.
Wait, why are we multiplying by 4? Because we're starting to plug it back into the equation. Sorry, I just lost all mental stability I've ever had.
Right.
Oh,
I think we've established that this is one problem. More importantly, you should say, Mrs. Moore, what is my next quiz going to be? And that is an excellent question. So your next quiz will be on Wednesday.
I literally thought you were
Usually
saying
Thursday. No, Wednesday. I see you. What day is today? Today's Thursday. So I see you Monday. Your next quiz will be on Wednesday.
Yes, let's go.
Well, I don't have it written down, so.
I don't even know what I'm doing, but we're having a quiz.
You can literally cry.
You have paper? That's the right
No,
small.
like, it's like 2
Oh,
rows.
no, I'm out of room.
I'm sorry.
Can you give us a sec?
Like, I don't think it's.
I am giving you a second.
We can tell them that was only something Yeah.
How would you supposed to? That's not a better action.
What last?
I did.
Wait, what's at the end? 0?
Yeah.
There's no plus 30.
Yeah, you're right.
Girl.
Okay, I'm gonna set equal to 30.
Wait, you're still going?
Yeah, she's,
You're done.
I'm done.
No, like that's.
It wraps around, yeah. it wraps
Oh.
Oh.
Oh my God.
There's only like 5.
Yeah, like 15 minutes left, North. I want to get my hopes up like that.
Why are you ending class early then?
Can you please do it?
No, it's not. It's not.
17 minutes.
I wish we should. I hate that.
Delicious.
What are we highlighting? I did.
Wait, Miss Moore, what are you doing?
I'm highlighting my X and Y's.
Oh.
Because I was pausing, if I didn't pause, I would start talking, and you would yell at me, so I don't yell at them.
I want to.
Alright,
What?
alright, I'm leaving the 4 here. I'm changing colors to the left. I'm leaving that 4 there. When I square this, it's the same thing that I did before. It's going to take 2 over the square root of 5 squared, which would be what? What? 4/5. So this will be 4. I'm going to write 4x squared over 5. Are you okay with that? Then when I multiply these two, I'm going to have 2 times 1, which is 2. Square root of 5 times square root of 5, which is 5, right? And I'm going to double it. So I'm going to have minus 2. Oh, actually, I'm going to have minus 4. Minus 4xy over 5.
Is it always gonna work out that we have this scheme?
It better work out. I'm gonna cry.
Yes, but actually, in this case, yes, because that denominator came from the hypotenuse of this, so yes.
Okay, so when we have the equivalence, it's always good.
Yeah. Then when I square this, I'm going to have y squared over 5. Everyone good? Here's that 4, not going to leave out that 4. Then when I multiply these two, I'm going to have 2x squared over 5. Minus 1 plus 4. That'd be 2. 2, I have to FOIL.
Why do I have to do this?
I don't know.
Oh, because I did right.
Now I'm going to multiply, when I multiply these two, this is my xy term. I'm going to have a negative 1 over 5 and plus a 4 over 5. So that will be 3.
Minus 3?
Plus 3.
Oh, sorry.
3 over 5xy?
Yeah.
Wait. Before you continue, can you just go off to the side and foil it on the board?
Okay, then when I get this one, this is plus 2y squared over 5. Oh, it is minus. So then when I FOIL this one, there's no coefficient, it's just y squared, right?
Correct.
So when I FOIL this, it's going to be this squared, so that's x squared over 5. Multiply those two and double it, so 1 times 2 would be 2, double that, that's going to be 4. 4xy over 5 And then square the last term, so that would be 4/5, and then the y squared.
What?
So now I'm still looping around here. So when I multiply this, the square root of 5 will simplify. Everyone good with that? So then I'm going to have, we'll take here, negative 4x, and then negative times the negative will be positive, so plus 2y.
Or not putting that over there.
No, because I simplified the square root of 5.
So you're doing the same thing for the next one?
So I'm doing the same thing for the next one. So I end up with plus 4x plus 8y is equal to 30.
I can see it.
Wait.
Or
Okay. Oh, you don't have to put it in
This is fun.
parentheses?
Doing good.
Wait, your X, Y's don't cancel out?
Yeah, they do. On this board?
They do?
Yeah.
I want my x, y term to cancel out, not my x's and my y's. Kelvin.
What happened to the negative 2 that you had outside? Doesn't that stay?
No, because we.
I did. Negative 2 times 2 gave that negative 4, negative 2 times the negative 1 gives it positive 2. Okay. These, the first 3 ones that are out there all have to denominate 5. I'm going to write them over 1 single 5. Are you with me?
Yeah.
I'm going to distribute the 4 and the 4 while I'm at it. Good?
Wait, what can you say that again?
I'm going to write everything with the first 3 parentheses are all with denominator 5.
Yeah.
So, and then I'm going to distribute this 4 and this 4 while I'm working on it.
Okay.
So I'm going to have 16x squared minus 16xy plus 4y squared plus 8x squared
So what
plus
is
y. This is all over 5. And then I'm going to combine my like terms while I'm down here to clean this up because I'm still looping around, right? These will be equal 0, and I'll have 10y is equal to 30. So this is plus the 10y is equal to 30. You with me? At this point, I might want to get rid of that 5. Do you want to get rid of that 5? I still want to get rid of that 5.
Wait, why'd you get?
Those, but isn't, it shouldn't be on the same line, or it is?
It is, but I remember now. So I'm going to multiply everything by 5. And when I do that,
Does that include the 10 line?
yes. So when I multiply everything by 5, this denominator will go away, and then these will each get multiplied by 5. Can I combine my terms while I'm doing that? Or is that too much?
Wait, you're,
Oh, I guess so.
you're fine now?
You can multiply.
So this becomes 50y, and this becomes 150. I multiply everything by 5. So, color coding. X squared, let's do x squared first, yes? So I have 16x squared, 8x squared, x squared.
30 times 5 is 145.
No, I think.
So I get 25x squared.
It is.
Okay.
My xy term, I have negative 16xy plus 12xy plus 4xy, that equals 0.
We did it right, guys.
4y squared minus 8y squared plus 4y squared, 0. 0y squared. So all this ends up being 25x squared plus 50y is equal to 150. I have one thing that's squared. So what kind of shape am I expecting it to be?
Parabola.
Parabola. At this point, what might I want to divide by? 25. So I'm going to divide everything by 25.
Oh.
So I'm going to have x squared plus 2y is equal to 6. So I'm going to,
All that.
x squared is equal to negative 2y plus 6.
Yay.
X squared is equal to -2, and then y plus 3. Because it's a parabola. So 4p is equal to -2, so 1p is equal to -1/2.
Oh, where's this P coming in?
Oh my gosh.
Okay. Alright, sorry. Yeah, because nobody else in this whole entire class had that same exact thought.
No, we all knew. Even I
Okay. So if I were to do a very rough sketch, it's going to be a very rough sketch. Here's my XY coordinate, yes? Going up here, my angle of rotation was about 26 degrees. So, like that-ish.
So you can just guess like that, and it's fine. The math, but it's not even exact.
I'm just doing a rough sketch, and I have the equation that I want. Just gonna stop.
You want to get a
But on the-
problem with it? It's fine, Nora. I understand where you're coming from.
Like, we do all that work, and then we just guess about that rotation, and then guess about where the point is.
Why don't you get a protractor?
You want to get a protractor?
No, that would, that's still wouldn't make it.
And I gotta see.
Laura, just don't put that in the first place.
I should get something that looks like that.
So wait,
How? The vertex HK, just like it was before, HK. This P, since this is negative, tells me that since the x is squared, I know it opens up or down. Since it's negative, I know it opens down. Remember, this is like my new x and this is my new y, so this is opening down. I can check it on my calculator. There's some other checks that you can use too.
Like check the balance?
So if I go to this here, if I look at this, if I were to rewrite this, when I finish this equation, my f's going to stay the same. So I had that 30, which is what I started with. So that's not one way I know I was right. The other way I know I was right is if I take a plus c. So going to my equation here, let's see, wrong way. Up here, my a is 4, my c is 4. I got a sum of 8, right?
yeah.
If I go down here, and, oh, I'm going to have 25.
You did it wrong.
No, it's right.
I don't think we're ever gonna have time to check it. So.
Yeah. And then this one, this is a discriminant. That's one we have to talk about. This is on your formula sheet. Before I even start this, I can decide what shape it's going to be by doing the discriminant. You should recognize the word discriminant for the quadratic formula. That's b squared minus 4ac. So if it's equal to 0, then I know it would be a parabola. So going back to this one. Oh my gosh, guys. A, b squared. So if I do b squared minus 4ac, and this is 4 squared minus 4 times 4 times 1, that is equal to 0. That's how I know it's going to be a parabola. So if you go to the next one
Wait.
that you have here, you have this is just asking you to classify. It's not asking you to do anything else. So if you classify it, you're going to do b squared, so negative 24 squared.
Wait, what problem are we doing now?
A.
How did we get there? Are we done?
Just guess.
Yo, before, are we done with it?
But the problem, yes, we graphed it.
Can you go back to it for a second?
Really, Joe, and I have it all right here.
I feel like every time I'm like, yo, can we chill? Like, do you
Here's a nice little graph.
All right,
Where have
thank
you
you.
been?
Wait, what is? Yeah, never mind.
You know it's hard to say, not
You just look at Aaron very good.
What is this when you put in your calculator?
Want me to work?
Steve's still
No,
here.
she's like,
Okay, try the next one,
How do we know it's correct?
because I'm looking at my formula sheet.
So we just try it for all of them.
This one, you're taking -4 squared minus 4ac. So this is 16 minus 824. It's a -8. Since it's negative, what shape is it?
Ellipse or circle.
It's an ellipse or a circle. And if I look at it,
Hey, there we go.
your homework is online.
I want